Let's go. Hi everyone and welcome to this conference about the security component. The goal of this conference is to let you discover and master the authentication part of the security component. Having a good understanding of it and its concept is necessary to be comfortable with it. But what is the best way to master it? The answer: by re-implementing the component together in about 40 minutes. Don't be afraid, all will be fine. Before beginning, let's see some info about myself. My name is Joseph Rouff. I'm 25 years old. I worked as web developer and lead developer for web agencies and startups like netvibes.com. And I worked since about 2 years at SensioLabs as R&D developer in Paris. And I worked mainly on the SensioLabs Insight products. For those wondering, there is no need to note anything. In fact, this conference is video recorded and will be available on the SensioLabs channel on YouTube. The slides will be available also at the end of the conference on this link. And all the examples we will see throughout the presentation will be available. You can execute and update them. The project name is How to Security Bundle on GitHub. Okay, let's see the content of this conference. We will start with the fact of use of the security component from a developer's point of view. Next, we will see how this conference can change the initial opinion. And finally, we will start the re-implementation together. So let's start with the opinion shared by most of Symfony 2 developers about the security component. The first fact of use is that the security component is globally misunderstood. From my point of view, there are two reasons for that. The first one is that there are lots of concepts to learn. There are there are 6 mandatory concepts and more than 10 optional concepts. Also, the authentication and authorization workflow is complex, and most of developers are afraid of it. As a reminder, we will focus during this conference only on the authentication part. A second fact of use is that most developers are lost beyond simple use cases. In fact, when developers have to deal with advanced use cases, in security, they try to apply recipes found on the internet without having a good understanding of the solution. Also, they try multiple solutions blindly until one of them matches approximately the business needs. And once a solution is found, the coded part is treated by developers like a black box which is forbidden to touch to not break anything. So it's really a bad thing. So let's see the goals now. The goals to reach at the end of this presentation are, if I do a good job and you too, because I will need your help throughout the presentation. The first one is knowing what each core concepts are used for. In fact, what is the responsibility of the firewall? What is the responsibility of the authentication listener? What is the responsibility of the token and the authentication provider? We will see each of them during this conference. A second goal is knowing when and how to add new implementation of these core concepts. And finally, we will see how to master our work on security instead of using it blindly. So, how can we reach these goals during a conference? As seen at the beginning, the best way to prove that the security component is not so difficult as it appears is to redevelop it from scratch in less than 40 minutes. To keep things simple to follow, the re-implementation will be based on a simple but real application user stories describing the business needs. And by re-implementing the component in this way, that will prove that each concept originally has a business need. And here it is, the great and complex application we need to secure by re-implementing the security component. Only 2 pages are needed, a home page and an admin page. So let's start the re-implementation. Let's begin with the first user story. Thanks to positive feedback, the application owner of the application owner heard about the simple security component, which is our re-implementation of the component. So the application owner said the following statement: the security of my app should be handled by the simple security component. To reach the end of this first user story, I will help you by asking you the following question. How can we listen each request received by a Symfony 2 application with the Symfony framework? Anyone? Yeah? A listener? Yeah? And yeah, exactly. An event subscriber subscribe to the kernel.request event. With this information, now we can see the implementation of this very first user story. So we go to GitHub on the project. We have, it is the first pull request, so we have related to the first user story. Here we have the title of the pull request as user story title, and you can click on this link to go back to the presentation. So let's see the changes. Everybody see? Yeah? Okay? So we created a file named firewall.php. This firewall.php implements the event subscriber interface of the real security component. So this event subscriber is responsible for analyzing each incoming HTTP request on the application. This class acts like a bridge or a connector between the security component and the application to protect. So without it, the security component is not aware of the application to protect. So it is very important. It is a very important concept. Because it is an event subscriber, a simple event subscriber, we have the static method getSubscribed event, and this method is telling to Symfony that we want to be notified of every request we made on the entire application. And Symfony 2 should fire the onKernel request method of this class each time a request is made on the application. So the onKernel request here can analyze now every request made on the application. So our re-implementation now is aware of the application to protect. So let's go back to the presentation. Let's see the concept introduced during this first user story. The only concept we saw is the firewall. The firewall intercepts and analyzes each incoming request. As a reminder, without it, it is impossible for the security component to be aware to protect the application. So it is a mandatory concept. Okay. To check if you really understand the concept we introduced, let's do a little quiz. Should I create a new firewall if my application is using Zend framework? For these first questions, I let you some extra time. Okay, anyone has an answer? No? We don't have to create a new firewall.
We need extra time.
No. So the answer is yes, we have to create a new firewall if my app is using Zen framework, because the Zen framework way to retrieve each incoming HTTP request on Zen framework application is different from the Symfony way. So we have to create a new firewall in this specific case. Now, same question with Cake PHP. Should I create a new firewall if my application is using Cake PHP? What? Yeah? Yeah, exactly. It is for the same reasons. Because the Cake PHP way to retrieve HTTP request is different from the Symfony way. And it not use the HTTP kernel component. And now for Silex. No? Why? What? Yeah, because it is based on the HTTP kernel component. So in this case, we don't have to create a new firewall. Okay. Now let's see the second user story. As a visitor, I should not be able to access the admin area. In fact, as of now, up to now, it is possible for everyone, even simple visitor, to access the admin area. So the application owner wants that this user story closed as soon as possible. To reach the end of this user story, two questions. The first one, how can we declare a URL as being part of the admin area? Anyone? It is what you do in the security.yaml, approximately. What? Yeah, with a URL pattern which matches all admins area. We have areas, admin, member, API, and we assign to it a pattern of URL, a URL pattern. Next question, how can we know if a request matches a pattern with Symfony?
You have to use a URL matcher.
Yeah, exactly. It is a request matcher. For this implementation, we use the request matcher. Now, let's see the implementation based on the info we have with the second user story. And we updated the firewall class here. We have a simple associative array with the admin area. This associative array describes areas which requires authentication. And we have as key the URL pattern and as value a collection of authentication listeners. We will see in the next user story the meaning of authentication listener. A little note is that in Symfony language, this array, firewalls, is named firewalls, but I prefer the term rules because a firewall which has a collection of firewalls, it's a little weird. So, and moreover, rules is semantically closer to real software, real firewall software. Now, let's see the on-kernel request. So, this on-kernel request, which is responsible to analyze every request, is iterating over all rules. And if one URL matches one of protected area, we set here a 401 HTTP response. And yeah, obviously, this is a temporary solution, as we will see in the next user story. But this solution allows to close this user story quickly. So, and I think here it is. Yeah, that's it. Now let's go back to the presentation. Let's see the concept we introduced. We introduced the concept of rule. which is also known as firewall in Symfony. It associates a URL pattern with one or many authentication listeners. It is what you do in the in your security.yaml, basically. Okay, now let's move on the third user story. Thanks our work on the second user story and the previous user story, when a user tries to access to the admin area, a 401 HTTP response, he receives a 401 HTTP response. This response tells him to sign in to access this area. But up to now, it is impossible. We don't have any, the user cannot be signed in. So the application owner said the following statement: I should be able to authenticate myself via the HTTP authentication mechanism. Okay, because this user story is the biggest part of this presentation, I split it into two sub-user stories. The first one is focusing on how to retrieve required data for authentication. And the second one is focusing on how to use retrieve data to try to authenticate the user. So, I want to retrieve required data for HTTP basic authentication. 3 questions. Where can I retrieve data for authentication in HTTP basic authentication? Yeah, it is in the request, in fact. And how can we recognize an authentication request among all regular requests in this case? What? If you have header, okay, what header? Yeah, authorization. And the authorization header we check is PHP auth user. This header should be available, and if it is available, it is an authentication request. Now, what other data is required to run the complete authentication process? Yeah, exactly. Exactly. We should use the PHP auth user and the PHP auth PW. Now, with this information, we can continue the implementation. And here, yeah, we make changes on firewall. We added on the admin area an HTTP basic authentication listener. We will see just above. And instead of set a 401 HTTP response, we iterate over all authentication listeners until one of them can handle or can support the current request. And let's see the HTTP authentication listener. This listener implements the listener interface of the real security component here, and it has a handle method, and the responsibility of the authentication listener is first to check if the current request is an authentication request. And if it is not the case, it should skip its turn. And if it supports the authentication request, it should retrieve from the request the required data to try to authenticate the user and embed them into a token. So, in fact, the listeners act as a bandmaster. It is like a controller for the security component because it manipulates all services related to security. Okay, and here we retrieve the request. If it is not an authentication request, in this particular case, we display an HTTP login box for the user to authenticate himself. So we have a 401 response with a www authenticate header. And if it is an authentication request, so we have the PHP auth user, the username, we embed these two info, PHP auth user and password, into a login password token. And here it is. We reach the end of this user story. And you can see that password is it's just a data class with just some getters and setters, nothing special. Okay, let's go back. Let's continue. So the concepts we introduced are the token. First, the token. The token is a data set related to authentication. In our case, we have a login password token, but if we use an auth authentication, we should create, for instance, O2 token. We discover the concept of authentication request. It is a request containing authentication data. In our case, it is the login and the password from the headers. And the last concept is the authentication listener. The authentication listener retrieves the data from the authentication request to launch the complete authentication process. Okay. Now that we have a token with data, the credentials sent by the user, we want to check, we want to authenticate this token. So 2 questions. The first one, how can we check the validity of a token in this case? Anyone? No? Okay. We have to compare the token data with the data of a data store. The data store can be a MySQL database, it can be LDAP, it can be an in-memory array, etc. Second question, how can we declare a token as authenticated? Yeah, set roles, okay. And in fact, we have to add roles to the token if we can authenticate it, and we have to set it into the security context. So let's see the implementation. In the firewall, we created an array authentication provider, and we inject it a simple array, which is our data source, with an admin as a login and a password with and role. Here it is an associative array, but it can be, as we saw, DBAL authentication provider. We can have LDAP authentication provider or whatever. And we inject this array provider and also the security context into the HTTP basic authentication listener. And now, here it is. Yeah, okay. We see the HTTP basic authentication listener. We just, the authentication listener asks the authentication provider to try to authenticate the token. And if it can authenticate the token, the authentication provider returns an authenticated token. And this authenticated token is set into the security context. And after this step, the user is considered as authenticated. And here it is. Now, let's see the array authentication. Yeah, here it is. The array authentication provider, it implements the authentication provider interface, and it has a method authenticate. and it iterates over all users he has into its data source, and if one of its users matches the data given to the token, we return an authenticated token. And this authenticated token, we inject into it the roles. And here it is. We have also a support method. This authentication provider says that it knows how to authenticate only the login password token. That's it. Okay. Let's see the concepts introduced. The first one is the authentication provider. The authentication provider attempts to transform the token into an authenticated token via a data source. Can be an LDAP directory, a MySQL database, or whatever. The second security context contains the second concept, the security context, contains the token of the connected user. The security context is accessible anywhere in the application. So, let's do a little quiz. Let's imagine that we have an application which uses the security component, but without any previous implementation of these three concepts: the authentication listener, the token, and the authentication provider. And the application owner wants to authenticate its user via form with the phone number and the password. Okay? Does it requires an authentication listener, a token, or an authentication provider? I also let you some extra time. So, anyone? For the first question, we have to create an authentication in this case?
In first cases, you should use different authentication listeners, but you can use same tokens and same auth providers.
Okay, but a little note is we don't have any previous implementation of this concept. So, we have to create each of them. And second question, in addition to the previous authentication mechanism, he wants to add the authentication mechanism via header, but with the same data, with the phone number and the password. So, does it require these three concepts? Only new authentication listener? Okay. Let's see. You are right, in fact. Why that? Because we can reuse the token and the authentication provider of the previous authentication mechanism. But the authentication listener, we have to retrieve the data no more from the request body, but from the request headers. So we have to create only an authentication listener. Now, the application owner wants an authentication based on Google+. So, does it require these three?
Yes, it requires this three new listener, token, and auth provider too.
Okay, and why?
Because you couldn't use a simple login password token.
Okay.
You don't have any passwords. You have to use a new auth provider.
Mm-hmm. Okay. In fact, because we have to create each of them because Google Plus is using OAuth2, the OAuth2 protocol. So we have to create each of them, the authentication listener, try to retrieve the no more phone number and password, but serial number which is sent by the O2 server. And same question for Facebook. In fact, no, we just have to create an authentication, an authentication provider in this case, because Facebook is using O2 also, like Google+, and we have to create an authentication provider because the data retrieved from Facebook can be different from Google+. So we have to create it. And anyone knows if I have to add an authentication, a Twitter authentication, I have to create these three concepts or not? Auth provider also? Alors, it is not, we have to create these three concepts because Twitter is using Auth1, and Auth1 requires different information from Auth2. So we have to create these three concepts. Okay. At this step, we did most of the re-implementation. We have seen the authentication workflow in detail, so normally you are now able to understand most of the real security components. But let's continue with the two last user stories. The application owner said the following statement: if I make a mistake while submitting credential, I should be able to retry authentication until they are correct. In fact, this behavior is not built into the security component. So to reach the end of this user story, a question: what response should be returned when submitted credentials are wrong? 401 redirect 401, yeah. You have just to create a 401 HTTP code with a www authenticate header. So let's see the implementation. How can we do that? We just have to add into our authentication listener a HTTP basic authentication entry point, and if the authentication provider can't authenticate the token, we catch the authentication exception, and in this case we set our 401 HTTP response, which is embedded into an authentication entry point. And that's all. So in our authentication provider, if no user matches the token data, we throw the authentication exception. And here it is, the HTTP basic entry point, which has a start method, and you can return any response. It can be a redirect response, it can be a 401 response or whatever, with this header to pop up the sign-in box. And that's all for this implementation. As a reminder, an entry point answers the question what to do if a user is not authenticated. So, the only concept introduced is the entry point. It allows to restart the authentication process, and it answers the question what to do if the current user is not authenticated or gives wrong credentials. Okay, let's finish with the last user story. Now I should be able to authenticate myself by sending my credential via the URL to avoid interactive login. In fact, he wants to avoid the interactive HTTP box of HTTP basic authentication. So 3 questions. It is the same as the user story 3. How can we recognize an authentication request in this case? Yeah.
Then we can see it contains in URL credentials or in body headers or something.
In fact, you just have to check if the current request query contains a username entry. If it contains a username entry, it is an authentication request. Now, next question, what other data is required to run the authentication process? The password, and you find where this password? Okay, in fact, in the request parameter. And so, does this user story need these three concepts? What? Okay, an authentication listener. Only? What? Okay, let's check that. And in fact, you are right. We just have to create an authentication listener. Why? Because we can reuse the token and the authentication provider. But the authentication listener, in this case, we retrieve the data no more from the header, but from the query. So we have to create a new authentication listener. So let's see this implementation, the last implementation. Okay, here we updated the firewall.php and we added another authentication listener here. Before the HTTP authentication listener, and the HTTP authentication listener acts as a fallback. So we inject into the URL authentication listener an array provider and the security context, and that's all. And we created a new implementation of authentication listener, URL authentication listener. It implements the same listener interface, and we check if it is an authentication request. And it is a mistake here. In fact, in this case, if it is not an authentication request, we have to return null to let the other authentication listener to try to authenticate. So we have to return null in this case. Otherwise, the basic authentication listener will never be fired. And if it is an authentication listener, here we embed the login and the password into the same login password token. We try to authenticate the token by asking to the authentication provider. If we can, we set the token, and we catch the authentication exception if the authentication listener can't authenticate the token, and in this case we set a response from the entry point. And here, that's all. That's all. So now, in conclusion, now, normally, you can master the core concepts of the authentication part, and you are now able to implement most of the authentication mechanism. And you can quickly and very easily learn optional concepts of the security component on your own. So if you have any question, I'm here, and I'm available on the hacking day. So thank you.